Okay, well, I will ignore that for the moment. Okay, so data recovery. So basically, and the only real reasons that I have this slide is because I also needed a forensic slide, and I needed to explain to people what data recovery was versus a forensics recovery. But the primary focus that I have on this is that it's when there isn't anything that's been redundant, even if it's only a short while ago, that you need to do data recovery versus a restoration or something like that. Believe it or not, this is a piece of content that comes up from time to time that I get people who have, say, a RAID array or a server that they're doing 24-hour backups on, and something died today after they worked 4 hours this morning. And I definitely understand the difference between like a company like Ford or somebody who might have 300 people keying stuff in and need to retain that material and get back to some sort of register if they send out checks, who knows what else happened, that they've got to recreate that process so that they know what the check numbers were, what went with some item. And I feel like that there is a difference between having to recreate a scenario that you've already done versus restore the process and get it running again. Because if I got a server from Ford and I would expect it to be a decently sized server, it will take me, even just if I knew exactly the layout of the data and processed it with a server that size, it could take me a week to export just the data that they need or to get to the piece that they need, depending on how large that piece is. But they may have a backup that they did yesterday. And I cannot believe how many times I actually have to tell the people this, because I get a box in the mail or somebody ships it or couriers it over to me or drives it. Somehow I get a box. And if I don't talk to them or I don't get actively involved in what their other process is, what I later find out is there's a bunch of people sitting around waiting on me to complete this process before they ever even started anything else. And the IT people feel like that they're mute, like they can't do anything until I have given them back a piece of data. Well, reinstall the tapes, get your Active Directory back up and running, get your server running again. The drives are inexpensive by comparison to whatever else that there is in the process. I seldom, I'm not going to say never, but I seldom need the box that the drives came out of. Most of the time, unless it's a rare situation where it is a large one, like a NetApp server or something like that, if it's any other RAID 5, RAID 6, any other standard configurations, any other thing that's done through anything that's commercially available that's not custom, I can do. Even HP compact server, they can do all those in software. I don't need hardware to do those. But I often have to tell them plan B. Get plan B going. Get all that stuff going. I'm not trying to meet you back with a booting server. That is really an incredible process. And most of the time, I want you to understand that what I'm giving you back, if you were doing this in real life, try to never give back the bootable thing. And I know that that's hard for people to understand or even take sometimes, like, oh, I had a Mac and it was running and it was bootable and I've now done an image and I've restored this process and I want it back exactly like it was. There's plenty of ways to get it back like it was, but there's a spot where it crosses from the data recovery guy to an IT person's job. Understand what I mean? So restoring a workstation and putting an icon back on a desktop, that's an IT guy's job. I give them the data to do so. In trying to put a machine back in running position. So for instance, let's say I'm imaging something and I've got 27 bad sectors. Unless I'm tracking those files and know what's in those positions, I don't know if it's a DLL, I don't know, like you can do it. There is a way to do it, but it is some work involved. You've got to have the right versions if you're going to singly replace files to get it back into a running position. If you get some that are missing sectors, then you're in a state where it may boot now, but later on, when it hits whatever it is that's damaged, it's going to crash. Then the client blames you. And now you're in another situation. You're in a situation where you've given them back something that's not perfectly running. They'll still blame you. It doesn't make any difference. It doesn't even matter if it was you that was involved. I mean, you could have had a perfect image of the server. You give them back a running server. In 2 weeks, their server crashes. You are the blame. I promise you. I've been in the situation where I've gone in, I fixed the server, I walked out, and they call me and say, our phones aren't working. What'd you do? Like, had nothing to do with your phones. I didn't touch your phones. I didn't touch a cable. I didn't touch anything. Had nothing to do with it. They will do that. They somehow always relate two things together no matter what it is. 5 seconds after you're gone, if there's no, oh, my car won't start. What'd you do? Like, I'm not, this isn't a joke. It really happens. And it's a really big thing sometimes. So my point is that you must always tell them to get plan B going, get something else up and running, and I will give you data. You will get a SQL database from me, and you need to re-import that SQL database. I'm not trying to give you that running thing. Now, if we cross that line, then that's a different, once I go into the realm of IT guy, now it's a very big expense. And I typically don't want to do that job. There's usually people on site. There's usually a large quantity of things for big companies that already have things in place. They don't normally need me to do that, and they're fine with it. If I talk to the IT guy, give him back something, here's your Exchange database, he knows what to do at that point in time, or we have a talk about it. But if they're waiting on you, I promise you, you will run into that situation where if you haven't talked to somebody, if you're doing this as a business, 7 days down the road, that you're like, well, why didn't you put a server back up? Why didn't you get your people keying again? Why didn't you get a continuation? And we'll build on that. So keep that in mind from that standpoint. Always make sure that you're at least communicating, especially if you know it's something complex like that. As opposed to forensics. Now, forensics is very simple from a standpoint of why we're calling it forensics, and I've had to explain this in court many times. It is anything that is scientific applied for a purpose of law. That's it. It means nothing else. It's science applied for law. And so this could be, I have to give a report after I'm done to a board. Typically in most law, there is actual law based on this, what those requirements are. It usually does fall under the requirements of private investigator, CPA, actual items for lawyers to be licensed. There is a process that is examined there and who they're reporting content to. And so if it's for a legal purpose, usually a board of a company also counts, or any kind of prosecutor / defense / court / any of those things. So the issue comes up as, and when are you crossing that line, when you're crossing into forensics, if I'm doing a data recovery and I'm just going to get a whole bunch of files back, and you've got Office on there, and you've got some photos and some pictures, if the client is asking me to look at the data, like that's kind of the key word. If he's asking you not if your program's run, can I open QuickBooks or something like that, once you get past that realm, they ask questions like this. Can you tell me if Carl emailed Elizabeth? Like, if they're saying that, that's forensics. You've already crossed into a line where they're saying, I want to examine some data, not I'm just looking at to make sure that my file is running. The other question that comes up will be things like, are there any pictures of any naked girls on there? Does he have any chats from Facebook? Is there, like, they'll ask questions like that. They never told you that when they sent you the drive. They never said that that's the specific things that they want. I have even had drives from police officers, and these are key things that happen to me. A police officer sends me a hard drive, and I'll see his name on that piece of, Sergeant blah, blah, blah. I'll call him. I'll pick up the phone. I'll call him and say, listen, I need to know if the thing that you sent me has contraband on it. If it has something that's illegal on it, I need to know this now. We either have to send it back to you, we need something else, we're going to need indemnification, we're going to need, like, if you knowingly possess child porn, you've got a problem. So there's things like that that happen in these kind of cases. And I'll ask them, and I swear to God, they will lie to me. No, this was my personal hard drive on my desk and didn't have anything to do with any cases. I just kept a couple Word documents on there. And then if you do the recovery and it turns out that that's the case, now you've got a different problem, right? So the other thing is that I'm very careful about any forensics cases not commingling the data with anything else. I don't want, like in a normal commercial data recovery process, if someone sends me a hard drive from home and I'm imaging the stuff, I can store it on my server, then I can later give them back their logical recovery. No one cares about documenting every single thing, and it's not going to court. It's not a big problem from that standpoint. If I have a forensics case and it is something that's, maybe it's just something simple like embezzlement or something like that, typically that's not something I want to commingle the data on my server. I'll keep them isolated. I'll keep them offline. I'll keep the data separate. I'll keep a clone. I'll keep it all offline. And if we're investigating something, that's the only time I'm going to be putting it online is to plug it into my machine. And that's about it. So I am very cautious about those kind of things. But I will tell you, you will run into many situations where lawyers and police or somebody does lie to you about what it is. And most of the time it's because of money. Like, I charge more if I'm doing forensics than I charge if I'm doing data recovery. I need a chain of custody, I've got duplicate stuff, I've got 3 times the work. And so I'll charge more for forensics. Most of the time I have an engagement letter and a whole process that you have to go through, as opposed to you just sign a form that says, I know I'm going to rip my hard drive apart and there's a warranty problem, and so therefore I'll send you the drive. And that's literally what's happened with the police that I've run into before that send me a drive, well, because they wanted an $800 price instead of a $1,200 or a $3,000 price. So just keep those things in mind. You know, everybody lies. They do. They almost always lie. It's pretty rare I even bother asking anybody anything anymore unless it's a case like that with a lawyer or something. But if I see law firms as a client and police or, you know, any agency, anything like that, I have literally had this happen before where I got something from the Navy and it had classified material in it. And they're not supposed to release that. It's not supposed to ever get to me. It's never supposed to happen. But it had a submarine plan on there. And not supposed to have it. Now, luckily, as soon as I recognize something, bam, I'm boxing that shit up and we're calling. Like, you get it. Let's get out of here. So, but you know, the contraband, you're supposed to call the police no matter what from that standpoint. So I let the police know if something happens. So if they have it on site and I can go work on site, that's a different scenario than it is them sending it to my office. And so that's what I want to happen. I'll go work at their office so they can fly me somewhere. But if you're doing commercial data recovery, there will be a time sooner or later that one of those crosses your desk. And you also need to know what the laws are about you doing the recovery. So if a law firm sends me a hard drive that might have multiple clients on it, and I'm doing the data recovery, I need to know what the law is that I need. Like in Georgia, I have to be a private investigator. And if you're not, and you're doing a case where you might have to report to court or you get called to testify, then you are admitting that you have committed a misdemeanor if you're not properly licensed. And they love to tear you apart on the other side. It's not usually your client that's the problem. It's usually the other side that's the problem. Or you get dragged into something that you didn't know you were going to get. And they'll always tell you this: we're not going to go to court over this issue. If they tell you that, you're going to court. I promise. You're going to court. If you ever hear those words, you're going to court. It's going to happen. So I hear that all the time. And because the thing is, they don't get to decide. It's often the other side who gets to decide. So if you've turned over evidence and you show, oh, well, this guy's got photos on his hard drive of him looking at porn, but he's in a corporate setting, he gets fired. Now he sues the company for improperly firing him. And you end up in another dispute where you get dragged in as the expert who turned over it. So you could do it without knowing all the time. If you're in Michigan, forensics is a felony. Did you know that? Forensics is a felony. If you perform forensics without a PI license in the state of Michigan, it is a felony. It is an actual crime that you will go to jail for. So the PIs actively pursue people. They're actively doing everything they can. They want it to be a felony in every state. They tried in Georgia, and I got lucky. I was able to stop them with the help of some friends. They forgot to exclude CPAs. And so I got the CPAs to actually, the whole board of the CPA went and met with the governor and stopped him from signing the law. But literally they forgot to exclude them. So I read every word in the document till I found the hole, and then called everybody I knew. So, but, and they've tried to pass it twice since then, but they haven't been able to. So far that's kind of what's been happening. But I did become a PI. It's still a law in the state of Georgia under misdemeanor that you have to be a PI. And usually to become a PI, it's like a 2-year apprenticeship unless you have some sort of other legal background. Like I used to be an ex-police officer. I could, maybe go and become a PI without that effort. But there's a whole story behind mine becoming a PI. But ultimately, that's what I need you to know. And this is the last time I'll say anything unless anybody asks me about it. But if you're doing your own business, somebody hands you a hard drive, you need to be aware of the things that might be on that hard drive that you could be now liable for. It can happen. It does happen. And you may need to be a private investigator. You have to look at the laws in your own state. They do not say, in most laws, they do not say computer forensics. The catch-all for almost every state is the PI laws. They are the last group in all of the professional licensing, so that if you're already a professional licensed person, say for a CPA, you already have a description. And when you get to the bottom of all of these others, and you go make it through hairdresser and all the other licensing, you'll get to the bottom, and it's PIs. And PIs will say, if you investigate any person to reveal any of their habits, criteria, personal information, anything like that, then you are, click an investigator. And if you are any of those things, then that's where it falls. And sooner or later, you will be asked that on the stand. So I've had my day. So it does absolutely nothing else for you otherwise. Most of the time, it's how to disassemble a gun, how to reassemble a gun, how they have cameras on the question that are old, 35 millimeter cameras, like nothing digital. Like all of these things are really old. They've been around for a long time, and very few of them have been updated for anything. And the closest you get to what we do for a living is maybe evidence handling. That's about it. And it's not nearly the description of what we do. So just so you know, I've been fighting it, but I am one. So I are that. All right, so that's enough. All right, now as far as the rest of this class goes, this is what we're going to be focusing on. There's the two physical types, the two types of recovery. One is physical, and the other one is logical. Now I'm going to go back and forth between these two pages for a minute. Logical is, I deleted the file and I'm going to recover it, or there's some other reason that some file is gone, / physically have to reconstruct something in order to get it back. When I'm saying a logical recovery, those are usually the only reasons that somebody is asking you to do a logical recovery. It's super rare you get a good drive that there's no physical damage to the drive or anything else before you're just getting good data. This is where forensics people normally live. They get good data or something close to good data, they've imaged it, now they've got something, and then they spend the rest of their life with this, going here forward. They never touch the previous stuff or anything other than, I got my data, right? So this is not what data recovery is, but this is what everybody believes data recovery is, because they're used to seeing on a website somewhere, download this Pandora data recovery software and you can extract all of these pictures and files and whatever else. And they believe that's data recovery, which is why almost all of them have failed, because all of those packages rely on the operating system's APIs to communicate to the hard drive. You understand what I mean? If I have to rely on the operating system, all operating systems are basically the same, no matter what brand it is that you're looking for, whether you're talking Mac, Linux, Windows, I don't care. DOS is the only one that's really different. DOS is slightly different than all the others in the fact that it actually communicates with hardware, whereas all the others have an API for your pretty window, and you're talking to a application programmer's interface in order to communicate with your hard drive. So you make a request to Windows, and Windows does the work for you. All you say is get net sector. That's really what all the request is. It doesn't have any intellect as far as what you're talking to as far as the hardware goes. So they all have exactly the same problem. How long are they expecting a hard drive to respond for every request? How long did I tell you? 600 milliseconds. So after 600 milliseconds, almost all of them will die. They will not communicate with the drive going forward. And the problem that exists may just be a time issue. It's slow, the sector's not responding well, the drive needs to retry more times than is allowable for 600 milliseconds. Okay? So keep that in mind. That's why all of these other pieces of software that normally try to do data recovery on a damaged piece of hardware fail. So logical recovery will be a small portion of what we're talking about in this class, because I'm going to deal mostly with all the physical stuff that happens beforehand, okay? So this, if you get to this spot, there's something else probably wrong. If I hook up a drive, it came in for data recovery, and it works, and I'm able to image it, and there's no bad sectors, whatever the problem is probably something they either didn't tell me, or I don't know at this point. I'll call them, I'll be like, hey, what are you looking for? Like, I try to at least give them a second to tell me what was happening. It is rare that I get a drive that's good when I hook it up. Understand that? That is really rare. Most of the time it will not be that. If it is that, it is probably something else they didn't define or tell me that they wanted afterwards. They sent it to me, I did the work. I didn't ask them a lot of questions in the process. Now I know what it is, then I'll ask them. And they'll say something like, well, my QuickBooks wasn't working right. And then I'll have to figure out what that meant. You know, does that make sense? So, you know, you don't even know. Some of these people have no idea. I can barely get the words out of them to tell me whether or not they own a Mac or a PC. Like, that's how bad it is. They don't even know most of the time anymore, do I have a Mac? Is there an Apple on the back? Why, yes, there is. Like, that's how bad it is. All right, so this is rarely, and we'll talk briefly about this, but this is where we live. The physical side. Something happened. Hardware died. Something doesn't connect. Something's not right. I mean, it could be simple. It could be a cable. It could be a fuse. It could be something. If another IT guy touched it before you got it, it's either worse or it was already really bad because even he couldn't do it. So it really depends on the technical capabilities of the IT guy. If there's a story from the IT guy, like other than I plugged it in and it didn't work, it clicked, so I sent it to you, his story might be, well, I swapped the board 3 or 4 times. Now, if he didn't know what he was doing, then your question is, which one was the original board? Because that's the ROM I need. And they almost don't ever know that either. It's pretty rare. So I'm just letting you know, this is the world that you're going to live in. If somebody else touched it when you got it, a screw is taken out, something's missing, you can always tell. It's pretty easy to tell if screws were taken out or something's missing. You do not know. It's pretty easy to change a board without you being able to tell. It is pretty hard to resolder. I can do it, but it's pretty rare that people can resolder a chip without you being able to tell that they resoldered it. You can do it with infrared. It is possible, and not with not much effort and not much practice. You could spend an hour learning to do it, and you could probably get pretty good enough you wouldn't be able to tell. But that's it. And so few people who are doing this as a one-off scenario are using infrared because they didn't buy the device. And it's not an expensive device. It's $150, $200. It used to be very expensive. It was starting at $600 just to begin with, but now the prices come way down. All right, anyway, you'll notice in this list, not only physical, I'm also putting passwords in this list. Now, I don't mean passwords like your Windows password. I mean passwords like the drive actually has a hardware password. That also might involve encryption. And generally, when I'm talking about this, I meant that the drive could be locked by a password. And again, this is a situation where the people don't even know what they have on their own. If you have an IBM ThinkPad or a Lenovo ThinkPad these days, and you start it up and it would have like a little red box and you would key in a password. I mean, it didn't even really say anything. It didn't even say password, it didn't say anything. The little red box, you have to type in your password and then you get access to the drive and the system boots. And you would be surprised again at how many people, they know they have to type that password when they first power up the machine, but unless they're sitting in front of it and they got the red box, they can't remember the password. And they didn't even know that was a password for the drive. They just thought it was a password to get into the machine. So they don't even know this when you call them or you need to talk to them about it. Now, we have options for clearing the password or discovering the password. Sometimes we can't discover the password depending on the model of the drive, but we can clear the password. We're just overriding it with a blank password, basically, is what's happening. But that is a firmware function. And firmware, again, is something that it rarely can be done on the, the Atola has a module for it and can sometimes get around it. The PC3000 is the best at clearing passwords if you had to deal with a password. I will tell you, I seldom have to deal with the password anymore. It used to be a fairly common thing that a couple of times a month, a hard drive would come in that's locked with a password that I might be able to get them to tell me, or I could just clear it. Now it's encryption. So now if it's encrypted, most of the time they're not asking for the password. So those are things that will come up, but I put them there because it's in firmware. So that's why I'm talking about it here. So otherwise, you could deal with a controller. I've also had controllers that write data incorrectly to the drive. And so we've had problems before where we've had to deal with corruption of the data in the process. And then I would put other stuff in here like RAID arrays and things like that that are hardware based and things that might fail otherwise. Okay, so these are the two basic types. We're going to formally be talking about physical. That's the majority of this week. 80% of this week is physical. Let's deal with that, okay? And then we'll talk about logical. Mostly we'll get to some logical on Wednesday, and it's mostly because after I've imaged a drive, I've got some corruption. I have to deal with the corruption or I won't be able to get something out. I've got many cases where something's corrupt inside the file systems table that's just enough that your forensic software won't even mount it or look at it. Data recovery software can or will be able to see it. And then the question is, how bad is it? Can I get around the problems? You need, and I'll explain this as we're going through, I almost always need that file system to somehow be somewhat functional to be able to get something good. Otherwise, the only way I can recover data is through a process called, what do you think? Carving, right? And if I'm carving, I'm getting the data, but I'm not getting anything surrounding the data, no metadata. And what that means is, and for those of you who don't have maybe a computer background from a standpoint of forensics or other stuff, fundamentally what that means is when I'm writing data on a hard drive, data is just always data. It doesn't know, there's no file name, there's no structure, there's no nothing with it. It's a chunk of, here's the beginning of my file, here's the end of my file. There's nothing inside there that identifies that and where it goes on your drive. It's a table that's keeping track of all of those things, that gives it a name, that gives it a date, that gives it its directory structure. Data is just data. If you put a picture on a drive, it's a picture on a drive. It doesn't matter whether or not it's a Mac, Linux, Windows. It doesn't make any difference. There's a couple of fundamental changes, but for the most part, it's just data. It's just raw data from here to here. No file name, no dates, no nothing, unless it happens to arbitrarily store that data for a name or a date inside the file like a JPEG might. But otherwise, it's just a raw chunk of data. And when you're carving, what happens is you're sending a tool that says, I know that a JPEG starts with FFD8 and that it ends in FFD9, so I will search for every FFD8 and every FFD9, and whatever those two are in the middle, I just chop it out and I give it a number. And I give it a number. A new version of Java is available, in case you guys are wondering. So that's the difference. It's mostly unusable, other than the fact somebody might have a JPEG that they're happy with, but then you have other problems. You have fragmentation, which is the biggest problem, which means your file isn't contiguous. It has other junk in between it. So you have a file that starts here, and then there wasn't a big enough hole for the operating system to write the whole file to, so it put the file here and a piece over here. And in between here and here is a Word document. So now when you cut that out and you get FFD8 and FFD9, there's a Word document involved in the middle, or something else. So we'll get to the carving scenario. I try to teach you everything I can to avoid carving as much as possible, because it is your last ditch effort. So many people use it as their first effort. Well, that's a terrible way to go about it. You do everything you can to figure out where the records are, what you can repair, get them running, but there are some scenarios where that's not possible. Okay, so we'll get around to that again. Now, in my recovery process that I've been doing for 20 years, this is basically how I've looked at everything from the beginning of time. Now, some things changed. And somewhere around 2008, 2009, I added this red arrow in because the tools got more advanced. And it no longer was just straight up plug something in, copy something, blah, blah, blah. Now the process involves the equipment doing its own diagnostics. Now, I'm not saying the tools do diagnostics. They don't really do diagnostics. The only tool that does diagnostics at all is Atola. The Atola has like this one button checkup, and what it does is it starts to run through all the items. It looks at the board, populates. It does exactly what I did when I wrote this piece for the F-22. It's doing a checkerboard test on memory, making sure that the board works. After the board works, it gets the registers back and says, okay, yes, the board is working fine. You don't have a problem here. Then it goes to the next level. And then it'll start stepping through the process. So it'll do checking your heads, seeing if the heads can read from the media in 3 different locations. There's a reason there's 3. We'll get to those 2. And then eventually getting to the file system and then telling you what you need to do. So it tries to tell you. The problem is if it fails at any one of those things, it might not know why it failed. So from then on, all it gets is red for everything else. So you don't know if you have a problem if something fails for some innocuous reason. So just because most of the time it'll get through a board, and then from then on it doesn't know anything about if your head fails, if the media is bad, if there's a scratch, it doesn't know any of that. So you do still have to evaluate it yourself manually looking at this process. PC2000 doesn't have a diagnostics mode. You can tell somewhat how good a drive is working, but there's not really a diagnostics mode. It's not or even the deep spark from that standpoint. But we have ways that we can tell what's working and not working by looking at the content that it's giving us. So I'll start stepping through those things. And that's why I have this red arrow, is that I'm typically now taking everything and either hooking it up to one of those 3 devices, starting to try to image, find out that I can't or there's something else wrong, looking at what's wrong, coming back to the step and repairing it, and then going back through the process again. So I'm constantly doing these 3 things over and over and over again till I get the best possible copy that I can get. Once I'm done and I've got the most perfect copy that's able to be gotten, then I'll do the logical. I'll be looking at the logical and then manually hunting things down that are damaged and repairing them by hand if I have to. So if somebody's got a QuickBooks file and it won't open for some reason, or I open it and you can sometimes see records are wrong, or there's 2 repetitive records. There's something wrong and a sector didn't read when you were imaging, and now you've got another sector that it's also replaced that content with because the database was corrupt. You can sometimes tell and use a hex editor and go in and fix those sectors. And that's a lot of manual work in the process, but it is possible to fix a database or something that won't mount, as opposed to a JPEG, which you might not even notice that there's a problem with 3 sectors. So we'll get into those things as well. All right. So your goal in doing the data recovery process and the rebuilds and all the stuff we're going to do is that you are going to recover the data from a drive that someone else gave you that is their data, and then you're going to, depending on what kind of agency you are or what you've gone, you're technically selling the data back, however you want to look at it. In order to justify your job, you still have to be good at doing your job. You still have to do basically the same process as anybody in the commercial industry, and then basically you're preserving your job by constantly being successful in selling that data back. Some people like to call it extortion. Some people like to negotiate on the back end. So this is another thing as a data recovery business. Once I've got the data for the client and I tell them that I've recovered all of your data, at that point in time when they know that I've got the data, they know I've already done all the work, and they will negotiate the price with me after the fact. So even though I've already told them in advance it's $800 or $1,000 or $10,000, doesn't make any difference. They'll be like, oh, so you've got all the data, then it's all good? Oh, well, that sounded very easy. How about $500? They'll do that. I'm not kidding you. Once that you've done the work, they try to renegotiate you down to the whole thing. And that's when, as an owner and the lead tech guy, I might not be making the wisest decision because I fire my client. That's usually what happens at that point in time. So I don't negotiate it with them. I'm like, I told you the price ahead of time. You even signed this document, so you know what the price is. And that's when some other business manager might negotiate and get the best of the deals for all the people he deals with. I'm like, I did so much work for this. I will delete all of your data before I ever give you an inch of this back. So it does make you mad. But anyway, this is the point. If you are doing this ever as a business, and you give them their data back because, they've got some hardship or whatever, they can't pay you till after they get their data, you will never get paid. If you give them the data back, it is super, super rare. Doesn't matter how good you were, doesn't matter if you're best friends, doesn't matter anything. I know from years of experience now, I'm doing this for 20 years, once they have whatever it is that they need, they're not going to give you $800. They're not going to give you $1,000. So few people keep their word or pay it, ever. Almost never. I might have had 3 out of 100 over all the years that actually owned up to what they said and actually paid for it. And they've got it. They don't need it anymore. If you don't have any repercussions or any way to get back at them, they'll take it. So I've had some that would do payments, and they'd make 3 payments and then they stop, and you never hear from them again, or they ghost you. So, and it doesn't make any difference. If it's data recovery, if it's a class, if it's a distance learning kit, it doesn't matter what it is. In my opinion, if once they've got it, they've got it. And they'll not pay you. So keep those in mind. All right, so that is your goal. The whole point that I'm going to try to get to here is what the hard drive companies are doing to you. Why are they making the choices that they are? Why is our hard drive so unreliable? And they constantly tell us how reliable it is. So the reason that all the hard drives are the way they are is because of areal density. Everything revolves around the hard drives based on areal density. They are trying to shrink that drive down to the smallest possible thing that they can do with the least cost of manufacturing it. So they'll do the least amount of material that is possible and be able to write the largest amount of data to the smallest location on the drive. So they're increasing areal density for the storage of the drive itself. And they will sacrifice your safety and your redundancy, and I mean, because they can make a drive that is very robust, that never dies. But they don't want to do that. They are specifically doing everything they can to be living on the bleeding edge, and you are dragged into that bleeding edge. And people seem more than happy to do that these days. They'll be happy with their 10 terabyte hard drive as long as it's 10 terabytes. It doesn't matter if it's safer or not. It is not safer. And they will make it worse and worse and worse for you. But the general public doesn't know this. They have no way of testing it. They're not getting feedback on this. Data recovery companies normally aren't posting or telling you all this stuff because that's their livelihood. If it's not dead, they're not making any money. So if they know how to fix it and they can get around it and they know what's wrong with it, that's how they live. So without that, they don't have anything. So areal density, and I will show you throughout history as we're going through all the way, every time we talk about something, I'll show you why something's not working and what continues to be a problem. They want the highest areal density possible. And any day that they do it, and here's the other thing I'll point out. These things are not being tested for very long before they're on the market. They are literally creating something. And when we're talking about lifespan and how long something lives before the technology is out, it has become like a short 2-year market at this point. So from the time that they pretty much invent something to the time that it hits the market, it's around about 2 years-ish for now. And that is quite a scenario for reliability for something new coming out. When they put on the drives, they'll put mean time between failures. They'll print, like it'll have it on a label or they'll put it in a book. They'll tell you there's a number that they quantify how long this drive should last. And they use mean time between failures. Well, they don't even have the drives long enough for them to have survived long enough for them to do an actual real test. So it's nothing but math and a calculation that they made up based on some previous technology that isn't this drive. It isn't this drive. It's a new number that they create specifically for this drive based on a menial amount of tests and previous technology that's similar to that. So it's a lie. It's literally a lie. It is, and it should be really obvious on solid state, it is a flat up lie because they'll say, oh, we can write more than 1 million times to the cell before. No, you can't. There almost no technology. There's very few. There's 1 or 2 people living on the edge that might have made something that might have lived once. But the higher the density gets for solid state drives, the worse the drive is by definition. And so, just so you know, old school NAND that existed years ago, that started out, and you'll never believe how old this is. How old do you think solid state really is? Flash, as you know Flash, when do you think it was made?
70s.
Pretty close. So, because most people would say 2001 or something like that, because that's when they started seeing the first flash drives. It was created in 1984. So it has been around for a really long time, but it was not feasible to purchase. It was very expensive to make the chips. It wasn't feasible to purchase it until we got into the 2000s, and then from there it kind of took off with newer technologies and things that they've used to create the NAND technology. But NAND is a mathematical format that's basically based on a grid. And so the data is laid out on a grid. And the data, originally, when you could write to those cells, it was using what's called a single layer in the single layer, you could write to the cells 100,000 times. So up until we started around 2005, 2006, we had nothing but SLC. And the first iPhone, the very first 2007 iPhone, is based on SLC technology. So it's a very robust technology that has existed for many, many years. And it is the... Anybody ever overclock a CPU? Yeah? Like gamers do it all the time and everything. They get a CPU and it's, you know, a smaller, slower speed, and they overclock it. And what happens after you've overclocked it for a while? What happens? Yep, eventually it lets the blue smoke out. Eventually it dies in the process. You've burned that chip out. It may have actually been able to run at that higher speed, but Intel usually, or whoever made the chip, usually lowers it because there's some problem with it and it's not as good as some of the other chips, so they divide them up into categories. The good ones are sold to the big company and the bad ones are sold to you. And so that's the way they've always done it. It's never been any different. And the same thing happens with NAND. But NAND started out as a single layer. It's a single cell, could only store an on and an off bit. That's it. It's either empty or it had electrons that were stored inside the cell. That's it. There was no other solution. Then they went to MLC, which is a multi-level bit, and then they went to triple bit, and God knows we may be at quad at this point. What happens is they overcharge the cell, and they use transistors to measure how much they're charging it. And if you take something that you're overcharging, you're going to do damage to it, and it's silicon. It's basically you're shoving more electrons in and then letting these electrons out, and the whole process damages it. When you let the electrons out, you're basically taking a large charge, like 20 volts, and putting it across the cell and allowing all the cell's energy to escape. And it does a small bit of damage every time that you read and write to these cells. So the problem becomes later on, as you start writing to them more and more, the larger amount that you're overcharging them causes them to die at a faster rate. So when we went from SLC, we went from 100,000 writes to a single cell to 10,000 writes in MLCs. MLCs immediately are cut to 10,000, so a factor of 10. And then triple bit it was supposed to be 5,000. We were supposed to cut it in half, but it turns out it's only 3,000 writes. So when you get to iPhone 10 or 11 that's storing content in triple bit, the cells themselves will die at a much, much faster rate. The only way you can make them survive is you add memory so that you cache things and you do a lot of work in memory before you write them out. So you can only do that to battery-operated things. Or you turn around and you write the data to another duplicate set of cells. So what they do is they expand an MLC or a triple bit so that instead of it actually being 64 gigs, what it really is 120 gigs. And they're just fooling you into believing it's 64 gigs by knobbing it off and giving you a larger amount of space. It might not be as large as 120. I've actually seen them, as much as 4 times as large as what they're selling. I work for some casinos, Caesars Palace, a few others, and we do testing on the machines that they create because they have to have a built-in system for doing accounting it has to be persistent. If the power goes out, doesn't matter what it is, they have to be able to recover those accounting files. So they have a small OEM drive that's a SATA. Oh, it's now SATA. They used to actually be a standard interface that went through IDE or others, but now they're all SATA. They're standard drives. And so the OEMs will send in a whole batch of things for me to test. And so I'll get ones from 10 different vendors so that I can test all the drives to tell them the lifespan of the drive and how long it's going to live. And I actually killed them. It's like a normal thing I do to see how fast I can kill a device. And usually I'm done within 2 to 3 months. Within 2 to 3 months, I've killed every solid state drive that I have touched by just powering the crap out of it, running data into it, and never letting it rest or anything. I just constantly am writing stuff. And every once in a while I get this one and I'll be like, man, this one's really living a long time. So I'll pull it apart. I don't normally take them apart right away. I look at the chipsets later. But so I take it apart and I pull out the chipsets And ones that they've been selling is 32 gigs and 64 gigs, which is more than enough for the accounting data to store, will end up being 512 gig drives. And it's a bait and switch thing. So what they do is they send you all the test ones that have 512 gigs on them so that you can never kill them or do anything. And they sold them to them as 32 or 64 gig drives. So later on, when they're on the production line, they'll change the chipset after they've already sent them to you for testing and you've already approved them. And so then 6 months or a year later, they're starting to die. And that's what's happening, is that they'll start out and they'll give you samples that have 512 gigs in them, so they wear level, and it's all software. It wear levels over all of the chipsets, so you're actually getting 4 to 10 times the lifespan, only because they've given you 4 to 10 times the amount of space. And so, so I make them, when they do that, I make them go pull them off of the line. So I'm like, hey, if they're going to bait and switch you, this is what's going to happen. And so they wait for 4 months in production, and then they have to go to the line and pick them off the line. Don't let them send them to you. You go visit the place and pull them. And sure enough, most of the time they're not the same. They'll even change the chipsets after production to a different chip altogether. So once that happens, and it's a real problem. If you have 1 million casino machines out in the field and they are all going to start dying, you can imagine the cost. It's not even just what you've lost, it's the manpower to go and replace them in the process. So you have to be really cautious about these things in the process. Anyway, so that's kind of, again, adding in the solid state stuff in the process. They are not better, they are worse. If I want something that's better, I need to take a time machine and go back and get my iPhone 1, because it will live far longer than any phone that we have today. Your iPhone 1, I would say, can still run today, except for none of the updates. So, right? So if you want a usable iPhone, I mean, I'm still using the iPhone 1, but I use it for music. So it's still running music. So, but outside of that. All right. Areal density. So basically, IBM created the drives that we have today. And everything else has been built around what IBM created to begin with. So the name of hard drives is not a hard drive. It's not any of the normal things that you're looking for. So when you look for hard drive data recovery, turns out there's very few books. Anybody look for books? It's pretty rare. There's only a couple of books, maybe at all. And most of them are not very good books. They're terrible books. But what you're really looking for, if you want to know anything about hard drives, is Mechatronics. That's the real word that you're searching for. There are real books written, and they're scientific-based books. There's at least 7 that I know of that I have read, and they are very expensive. They're kind of like a fancy white paper, printed in a hard book. And so each one of the people that wrote these books were scientists. They were not your normal run-of-the-mill guy writing a story. So the beginning of the books usually starts out with a little bit of how I got involved with this for like 2 chapters or 3 chapters, and then it switches to math. And then it's math from there to the end of the book. But they do describe in detail, whenever they're talking about these things, quite a bit about how they came to the conclusions that they did. The other weird thing about them, when you read any of the Mechatronics books, is that the scientist that created whatever he created only created that one thing. So if he worked on the heads of a hard drive, then that's the only thing he worked on. He didn't work on the servo writer and the data that's written to the processor, the board, the zone tables. So he doesn't know any of that stuff. And he doesn't write about any of that stuff. So you've got to cross-reference them in other books. But I will tell you, if you search for them, there's a handful of them. And there's one specifically called Mechatronics that's got a brown cover on it. That is a very good book. It's probably the best of the sets. And there is another book that's specific about servo writing information. And so if you really want to know the stuff, there is a book there, and I've read them. And there is one more that you would need, which is called Perpendicular Encoding. There is another book that's specific about how you write and switch from what's called longitudinal encoding to perpendicular encoding. After 2006, every single thing switched to perpendicular encoding. We no longer use longitudinal encoding. I will tell you what those things are shortly. So those are the primary 3 that are out there. Like I said, there's 7 or 8 of them. I've got them all. And there is another book that's a story book. It's written by Gordon Hughes. Gordon Hughes is the guy who designed the erasure process that exists on hard drives today, how you erase the drives. And Gordon Hughes has been around working in hard drive industries all the way back to the 70s. And so he has a book, it's actually called Hard Drive is the name of the story. But it's a book about the story of hard drives and how his involvement was throughout the years. So it's a little more of a story book than a mathematical book. So those are some of the best ones that you can find that break things down for you. There's not a lot other. If I want to go outside of this as far as materials and books go, I go to the patents and search for Mechatronics. So if you go to the patent library and search for them, now the problem with patents, if you're doing research on how something works, is that not everything in the patent was implemented. So they'll tell you a nice little story about how this is supposed to work and how something's supposed to be done and how they're designing this thing. But then when they get into the practical part, they may not have done that. So you'll see some things, and if you know anything about the drive and what you're working on, you can kind of ascertain what has happened. That he was working on this, this was a good part, and then bam, something happened because this makes no sense. This piece is not what the drive is doing, and this doesn't. So there is a chunk like that. So keep that in mind as you're going through it. This was a term that was coined by the Japanese basically during the manufacturing process because they combined mechanical and electronics. So in the 70s, you can see when that started to happen. We've had quite an evolution since then. So 1956 was pretty much when the very first hard drive that we know as a hard drive, that wasn't bubble storage or core memory like other choices that you had for storage prior to that. It's the first type of hard drive that we had. It looked like this orange one right here. And so basically the big difference between this drive, which is a later model, this is the second set that was produced after 1961. So in 1956, the heads rubbed on the platter. They never left the platter. The heads were sitting on the platter while they were reading and writing data. Now, it works kind of like an H. So they had two edges, and the edges are what was rubbing on the platter. The center was where the head was, and it was above that area, so that did not rub on the platter. So you had tracks, and everything's done in a track. So as long as it was in a track, your head would move to that location, and it would be rubbing the two edges of the track, and the center would be left open. So basically where you see all the grease on the road now between the tires of your car. Like that part would be the part you would be reading, and where the tires rub the road down, where it looks a little bit more worn, that part's getting eaten away. So that's typically what you're looking at as far as these drives go. So IBM installed these things and actually made mini mainframes basically that they were selling. Mainframes are how you know of minis and micros and mainframes. Once we actually got to micros, we're at like AS400s. So in this realm, those drives had to be mirrored. Those drives, before RAID was ever a word, RAID was not actually coined as a word until the 80s. But these were mirrors. They actually were mirroring these drives because they knew they were doing damage to the drives. They're rubbing the drives, so they would install these in pairs. You would either get the two dishwasher version, which looked like two big machines next to each other. They later made these with disc packs, so they were removable. Or you got the part where they hung on arms, and there were two on an arm, and they swung in and out like this. And so whenever something died, they could pull one arm out, replace the drive itself, and then put it all back together and mirror it back again until the next drive died. So you bought these service contracts that were super expensive, and part of the reasons that they were super expensive was because there was another one of these somewhere in stock somewhere waiting for your drive to die. So they were buying these drives. This thing weighs like 70 pounds. It's no joke. This is huge. This thing is this high. It's that high. From the ground to here is this high. That motor right there is like 40 or 50 pounds of the weight. So, and this is basically the actuator arm in the process. It jams the heads in and out. We'll talk about that in a minute. Because these are your standards. This is a 3.5 inch drive, so you can see compared to a 3.5 inch drive how big that is. So that's a huge drive and quite heavy. And so right now I took two of those and I made a table. So they're the legs of the table, and it's a glass table. So I have a glass table you can see through, and these two are standing up on end as the legs of the table. It's a pretty cool table, but In 1961, they started flying the heads over the platter. They figured out a trick, and the trick is this. You can make it hover at the same height without digging into the edge of the platter if you gradually cut off little pieces of metal off of the suspension, off of the gimbal, till it worked like an airplane. So basically you're creating, when the platter spins up, every platter when it spins up creates a surface tension of air across the top of the platter. And that surface tension is called the air-bearing surface. So the air-bearing surface will push up on whatever it is, and they actually were fighting it before. They were trying to create enough metal basically to hold it down onto the platter. So they eventually figure out, if I cut it, and I cut out certain pieces of metal, that it creates just enough tension that when it spins up, it pushes up on the head, and the head will fly at the same height as long as I cut the right amount. Does that make sense? So this becomes a wing of an airplane. Now, you'll also notice on these IBM drives that there's two sets of heads. There's a head there, and there's a head here. And so this head was the inner head, and this head is the outer head. And so when it would jam into the drive, this one only had to read those tracks, and this one would read the rest of those tracks. So from here to here. You'll also see this green wire that goes down for each head. So there's a green one, there's a white one. This is exactly what it looks like on current heads today as you're looking at them down the side. Usually not in the middle, most of the time it's on the side. It'll run out here and then run down. But those are how you know which drives have live head on them. It's by looking at the wire. So this is physically what they're doing to create the air-bearing surface so that the drive's head will fly over the platter. And so from 1961 on, every drive has pretty much had their heads flying over the platters based on that same technology from then forward. And then they designed the removable disc packs, which was actually my first job. When I was 18 years old, I got hired by the company that made Sears catalogs to do backups. My first job was backups, ironically, of these disc packs. They looked exactly like this big orange one, but they didn't have this motor. There was just this part right here and a big blue handle on it, and you screw them in. And the company I worked for had 36 of them. And in a weekend from 5 o'clock to Monday morning, all 36 had to be copied. They take 6 hours each. So that was my job, was to stay there all weekend and get paid to swap disc packs, control the computers, do backups. So I have a lot of experience with that. This is back with Kennedy tapes and the whole thing. Like, I did all of this. And then Fort Knox had a division where they would actually do like off-site storage. They would come in and pick up the drives and deliver it. I don't think they took them to Fort Knox. I just think they had local storage somewhere and they took them off-site. So somebody shows up, takes them off-site in case something bad happens to your building. So anyway, that was my first job, and spent like 2 years doing that. And so basically from then on, then we end up heading into what we start as, this is not quite PC error yet, but this is like the beginning when we start looking at Winchester drives and heading into what would be the PC error, because the PC error didn't technically start, or at least as far as IBM is concerned, until 1982. Prior to that, obviously we had Apple stuff that had been in existence pretty much since 76 on. And I have experience with everything. I was there for all of it. So I have these millions of stories that I think all the books and all the movies are wrong because I was there for it. And I saw the stuff on a daily basis because as a kid, those are my teenage years, I could not afford to even get magazines or do anything. So I go to the store and I would stand there in the aisle and I read every single magazine that there was on computers, which wasn't many. And I pretty much did that until I was like in my 20s, like early 20s, and read every single thing or was involved in every single thing at some point in time. It was what I wanted to do since I was like 12 years old. And I can tell you that a lot of the stories that you hear today about how things happened is wrong. It's absolutely wrong. And so we'll get into this shortly, or some of the stuff. All right, so again, this is what we're looking at as far as the first hard drives go. Then we ended up getting into 3.5-inch drives. And then there was a 5.25-inch hard drive. This was called a Quantum Bigfoot. And this is a trick, actually. Technically, this would be a trick.